AP Calculus! We are here today without Rochelle on this beautiful December 10th. So let's go ahead and fill in the date. 12 slash, already getting some lag. 12/10. Say hello to Rochelle.
Hi.
Okay. Arrow is just doing her little smug little thing. She wishes that you were here. She misses you. Solutions to differential equations. Yeah, so general particular solutions. So we're doing solutions today on these really hard differential equations. Let's see how they work. First, let's talk about the graphical representation of what's going on. So when I talk about the general solution, you'll have the function. You'll be able to solve for the function. Let's say the function was a quadratic. So we're graphing a parabola. So boom, there is one solution. But because it's a general solution, we don't know what our constant of integration is. So general solution, and we saw this before, it could be here, it could be here, it could be here. Those are all general solutions. We don't know what plus c is. I mean, if it was plus 1, then it would be this graph right here. If it was plus 0, then it would be this graph right here. But in general, you'll have some blah, blah, blah stuff plus some blah, blah, blah stuff, or maybe an equal to blah, blah, blah stuff. We don't know exactly what goes in those rectangles. It might be a quadratic. It might be some weird circle that's not even defined. But in general, it's plus c here. And I need to have slightly better handwriting, plus c. We don't know what the constant of integration is, therefore it is a general solution. And that's what today's lesson is about. The particular solution, that's going to be tomorrow's lesson 6-3. The particular solution will be something where it says, hey, you have this point right here, which happens to be, I don't know, 1, 0, that you need to have plugged into the general solution, and you need to figure out what that constant of integration is. So you have basically the same thing, something is equal to something else, and then you say, I don't know, minus 2. Maybe that's a minus 2 right there. You actually know what that constant of integration is. So particular solution, finding what that constant of integration is, and that constant of integration, to find that is really, really hard, but you guys can do it. All right, so let's say we start with this differential equation. dy dx, the derivative of y with respect to x is equal to x squared over y. That's what we're going to start with. Here is the procedure. We're going to do steps 1 through 3 today, and then we're going to talk about why we're not doing step 4 today. All right, so step 1, we're going to separate. And all of these sound really nice. Separate, integrate, evaluate, isolate. They ring off the tongue. They're nice. John spent a long time figuring out how to make this easy to remember. But first, you need to have two fractions set equal to each other. That way you know that you're cross-multiplying. So you need something divided by something else is equal to something divided by something else. Make sure you have two fractions set equal to one each other. I can't speak. Equal to each other. So if you don't like that, you can say a fraction is equal to a fraction. And hey, we already have that. We're done. Look at that. dy dx is equal to x squared over y. We have a fraction equal to a fraction. So once you have a fraction equal to a fraction, you are on to the next step inside of separate, which is to cross multiply. We are going to cross multiply, and that will give us, I can do this in orange, so y times dy is y dy, and then x squared times dx is going to be equal to x squared dx. And then the next step in the little block here of separate is to separate the x and y. X and y. And by separate, I just mean get all the x's on one side, all of the y's on the other side. And just as a note, I know that a lot of us are really confident in trying to isolate the y's on one side and x's on the other sides, but you are almost never going to subtract. You're almost always going to divide if you need to. In this case, you don't need to do anything because all the x's are on one side and all the y's are on the other. But just as a note, if you have something like y dx is equal to x dy, after you cross multiply, then don't subtract a y from both sides, divide. Make sure you're dividing. So we'll say just divide. Don't subtract. I don't think that's going to be a common error in this class. It was in the last class where a few girls would try to subtract y and subtract x from both sides. Just divide both sides by y, divide both sides by x, and you'll be left with a fraction, which is okay. And we'll see that in one of our examples. Don't subtract, only divide. Okay, so now we're on to the second step, integrate. So we have everything isolated. We have all the y's on one side, all the x's on the other. Now we're going to just write the integral on both sides. So when I do that, I'm going to have the integral of y dy is equal to the integral of x squared dx. And then you actually take the antiderivative. So antiderivative of y, you guys can help me out here. Antiderivative of y is
capital Y?
Nope. Think of it like x, because it's with respect to y. So if I did the antiderivative of x, it would be
1/2 y squared.
yes. So y squared, and then you have to divide by 2, so 1/2 of that. So y squared over 2, that works. And then normally you would write plus c, right? Here's the catch. You only need 1 plus c, and generally speaking, I've done maybe 8 of these problems where you do like the full problem, so that giant step 4. You almost always want to put the constant of integration with the x. And usually you want the y's on the left because that's going to be your short little bit. So that's going to be equal to antiderivative on the right, x squared. Antiderivative is arrow. X to the third divided by 3, perfect. And then I'm going to do my constant of integration on the right-hand side with the x. The general rule of thumb is, and I'll write this on the side notes, the plus c on the x side. And generally you want the y side on the left just to make sure that you're consistent. If you keep mixing up where the y's are on the right-hand side for half of your problems, then it'll be a little bit more confusing to see the steps. But if you do the same thing over and over, then you'll see it. So what did we not forget to do? Yeah, don't forget plus c. Don't forget that constant of integration. All right, that was step 2. Pretty easy. Just make sure you know how to do antiderivative. Make sure you know all those special rules for natural logarithms, if it's going to be absolute value, stuff like that. And then you're on to the last step that I'm going to be teaching today, which is to evaluate. And this is the easiest step. Another word for evaluate is what? We're actually substituting. It's called, just plug in.
You're overthinking.
Yeah, don't overthink it. So and this is a giant if they give you, well, they always will on the AP Calculus exam, but in terms of the homework, I don't let you evaluate until you're on step 11 and then step 12. So for the first 10 problems, you're doing just step 1 and 2 over and over again, and then finally by number 11, you're going to do step 3. You're not even going to do step 4 today. So step 3, plug in. If they give you x and y values, plug in those x and y values to your antiderivative, and you have gotten a ton of points on this problem. And now it's time to actually talk about those points.
This is free response?
This is free response. Everything from Unit 6 all the way to Unit 11. I think we stopped with Unit 11. I'll have to double check that. But for the rest of the year, we're only doing free response with like 5 multiple choice questions on each practice test and test. Just to review.
It's like half the AP exam free response?
Exactly, yeah. That's the reason why we have half our units free response and half of them multiple choice. It just matches with what the AP test does.
But is it going to be the same units free response on the
No,
test?
that's mostly true, but no. All right, so let's talk about step 4, isolate. Isolate is when you're actually trying to get C by itself, and yeah, you're isolating the constant of integration to find what that constant of integration is. So if you isolate, that's just another way of saying well, I guess it's getting constant of integration by itself, but by the end, you're getting y by itself. So we'll say get y by itself. And I guess it's not really in my notes from last year, but I know from doing this a ton of times last year, you have to find your constant of integration, and that is the hard part. Finding that C is so hard. Like obviously getting y by itself is pretty easy. Like, oh look, in this problem you just multiply both sides by 2. Whoa, so hard. But finding that constant of integration, that's the really, really hard part. And yeah, I'll talk about it tomorrow, but just know it's going to be a hard problem. So isolate. You don't actually need to know this. So you don't need to know. Don't need to know. I'm going to underline need. Don't need for AP test. But why don't you need it, Mr. Snell? Well, it's because, and it's that thing that we talked about at the very beginning. It requires a lot of work. Lots of work. For little points. The ratio of work to points is it's so far off the charts that it's sometimes not worth learning. All right. So let me talk, and I I ran out of room because we have to do so much examples on the back, and these are kind of big. I want to talk about the scoring. It should be in its own category, and this got kind of condensed. But in terms of the entire AP test, so on an AP test, do you guys know what passing is? What score do you need out of 5?
3, right?
Yep. 3 is considered passing. And I don't like the word passing for this class. I think that if you take the AP test, you have passed, and maybe passed in my heart is a good way of saying that. 3 is how you get credit. You get credit at schools from getting a 3, and if you go to like some crazy school like, I don't know, Berkeley probably won't give you credit for 3. They'll only give you credit for 5 because it's like one of those really high-end schools. Really high-end schools might not even give you a credit for 5. Like, they're really picky about that. They're like, well, you need a 5 to get into this school, but then we're not going to give you credit because we want you to retake it the correct way. And their logic for that is pretty sound. If you want to talk about that more, I'll talk about why they do that. But it does make sense. It's not some weird thing. It's like, why are you doing that? Anyway, so 3 is passing. Each free response, so each FRQ, and I abbreviate free response question, each free response question is 9 points. There are a total of 6 free response questions, by the way. So 6 times 9, that's 54 points. The whole test is out of 108 points. 54 is half of 108, so there's half of your points. So each free response question is 9 points. In order to get a 3, to get that passing score, to get this 3 that I'm talking about right up here, to get that passing score, guess how many points you need on each free response question on average? You need a 3 out of 9 points. On average. Obviously, if you get 1 out of 9 points on one, well, you need to make that up and you get 5 out of 9 points on the other. To get a passing score, obviously, if you're shooting for the 5, you need, I think you probably only need 5 out of 9. It's not that much higher. But we're gaming the system here. So by the step 3, by evaluate, so by step 3, by our evaluate step, you will have 3 to 6, or sorry, not 3 to 7. You'll have 6 to 7 points, which is crazy. What this means is if you average by getting 100% on these first 3 steps, you'll get a 5 on average.
So you should just do these 3 steps, move on, and then if you have time, come back, do 4.
Yes, the problem with that is step 3 gets in the way of step 4. Really, if I did all these 4 steps and I knew I was going to do them, so if I know that I'm Ben and I'm going to be doing these, really the steps are 1, 2, 4, 3. Or I guess 3 and 4 kind of at the same time. It'll be more clear after tomorrow. It'll be clear after tomorrow. But just generally, cut off right here, you'll get a 5. You're fine. That's the additional step. Okay, let's actually do those first 3 steps. Well, I guess first 2 steps since I don't have a point to plug in. If I said, let's just make this one at the point 1, 2. That way we have step 3. Sure. All right, talk me through this one. Walk me through it. What am I going to do? See if you can remember. If you can't remember, look at the front. Try to do it from memory.
Cross multiply.
Cross multiply, because it's already a fraction equal to a fraction. When I cross multiply, I get x dy is equal to 3y dx. All right. That's a problem because we still haven't done step 1, which is to isolate. We need to isolate, or it's not isolate, it's separate. We still haven't separated yet because the y's are not all on the same side. So what am I going to do? Yeah, divide both sides by x, divide both sides by x. We can also divide both sides by y. Divide both sides by y, divide both sides by y. Those x's cancel out, those y's cancel out, and I'm left with this new equation that says 1 over y dy is equal to 3 over x dx. All right, are we done with step 1? We are. We have all the x's on the same side, all the y's on the same side. What's step 2? What's the word for step 2 that you need to have memorized?
Integrate.
Integrate, there it is. And when you integrate, don't forget
C.
plus c, yep. All right, so when we integrate both sides, let's go ahead and rewrite it. Integral of 1 over y dy is equal to the integral of 3 over x dx. I need to take the antiderivative. I'm on step 2 now, so I'm going to say that's step 2. We were doing all of step 1. Step 1 was right there, so step 2. And I take the antiderivative. Antiderivative of 1 over y dy is, you should just know the top of your head by now, hopefully. If not, that's okay. You'll definitely get it.
ln y.
Natural log of y. And is it absolute value or not?
Probably absolute value.
What do you think, Arrow?
Yeah.
It could be a negative. Yeah, I could choose to have a negative value for y. So
But it's not necessary in this problem, right?
Well, you might
This
as well.
it is necessary, and that's why step 4 is so hard. Yep.
Oh no.
Because you have to undo an absolute value sign. Yep. Natural log of absolute value of y. That's the antiderivative. Normally we put a plus c, but I told you guys, try to put your plus c with your x's. So that's going to be equal to, and I should be doing all this in a different color. I should change this to, let's go to black, sure. All right. Natural log of y. Antiderivative of the right-hand side is
3 ln x.
3 natural log of, it's not just x,
Absolute value.
absolute value of x, yep. Because of domain. You can't plug in a negative value to absolute value or to natural logarithm. So it's not in the domain. Make sure it is the domain by having absolute value. And don't forget, yeah, c, plus c. We'll put it on the x side. We have just finished step 2. We have taken the antiderivative. What's step 3? Plug it in, yep. So when I do step 3, I plug it in. I could actually do step 3 right here because it's so easy to do. Step 3, I'm plugging in 1 for x, 2 for y, so I get the natural log of 2. And I guess I don't need absolute value at this point because it is already 2 is equal to 3 natural logarithm of 1, which happens to be 0, plus c. And if you want to simplify that, you can. In my class, you have to. On the AP test, you should not. Because it's in my class and all of it is going to be free response, you need to practice working on simplifying. So this now simplifies for my class as the natural logarithm of 2, just in parentheses, is equal to c. And done. You don't need a, well, I guess you can.
So we did find the constant of
No, you did find the constant of integration, which means step 4 is really easy. They will never be that easy on the AP test. I should have chosen a different point. I'll make a note for next year. Next year, change that to a 2 or a 3 or something. All right. Example 2. Let's go ahead and evaluate this one for negative y. Let's go at the point 3, 5. I know nothing is going to work there because, yeah, I definitely know. Okay, so what am I going to do? What are my steps? Step 1. What's
multiply? Because it's just negative 1 over 1.
Yeah.
So it starts with an S. Step 1 is separate. Yep. And notice that we don't have a fraction here. You can still cross multiply. I think that you guys are really smart and you can see, oh, that's just over 1, and then you cross multiply that way. Make sure you do know that though. So I'm multiplying 1, so I get 1 times dy. 1 dy is equal to negative y dx. Arrow did this step last time, so Ben, you're going to do this step now.
Divide by negative y.
Divide both sides by negative y. Divide both sides by negative y. And I get, Arrow, what is my final answer for step 1 for separate?
Negative dx equals.
Ooh, so be careful. So we are dividing by negative negative y.
Fine. Okay. You put the dx on the other side too. Oh, okay, whatever. Dx equals negative 1 over y.
Okay, so
Yeah.
you're correct. And just as kind of a way of making sure that we're always the same, especially if you're going to plan on doing step 4, try to make it so that the y's are on the left-hand side.
Yeah.
So what do I have on the left-hand side?
Negative 1 over y.
Negative 1 over y and dx. Perfect. So that was all step 1. Let's do step 2 right here. What's the word for step 2? Ben got it last time.
With the swirly things.
Integrate.
Integrate, yeah. So just write the integral of negative 1 over y. I forgot my dy over here. 1 over y dy is equal to just 1 dx. If there's nothing there, you can always think of that as 1. Or you can just think of it as dx if you're comfortable with that. All right, take the antiderivative of the left and the right. One of you is going to do one, the other is going to do the other.
I'll do right.
Okay, Errol, you're doing left.
Yeah.
He gave you the harder part.
Oh.
You guys are working on it. And what do I get?
Negative natural log of the absolute value of y.
Negative natural log of absolute value of y. You said that perfectly. And then Ben?
Equals x plus c.
X plus c. There it is. And he didn't forget his constant of integration. That's good. And let's go on to step number 3, which is plugging in. And what is the word that we use for step 3? Ends with an 8. Integrate, separate. Step 3 is?
Recreate.
No.
Like
Plug in reate.
So,
It starts with an E.
elaborate. No.
E.
Extrapolate. I think it's probably one.
It's evaluate.
Oh.
Okay. Evaluate, which means we're plugging in. You guys knew that you're plugging in. So negative natural log of absolute value. We don't really need absolute value because we know that we're plugging in a 5 is equal to 3 plus c. And this one would be that easier type for step 4 that you could definitely do. Okay, that's all we have for the notes today. We know how to do steps 1 through 3. Any questions? All right, go ahead and do your summaries.